American aviation has long been the birthplace of great innovation, from the Wright brothers to NASA's space program. Hello everyone, welcome back to Military Notes. However, when it comes to hypersonic flight, courage and innovation alone are not enough. A real technological revolution is needed. American-based startup Hermus is here to answer this challenge with a vision to speed air travel to levels never before achieved. Hermus is building a hypersonic aircraft designed to change the way humans travel around the world. More than 2 decades have passed since the legendary Concorde supersonic aircraft retired in November 2003. The aircraft became an icon of speed, capable of flying from New York to London in less than 3 hours, with a top speed of 1,354 miles per hour. However, the speed of the Concorde is still far below the hypersonic category, which starts at Mach 5, or around 3,836 miles per hour. In addition, restrictions on supersonic flights over the United States mainland also limited Concorde operations, so that most high-speed flights could only be achieved over certain areas, such as Canada, which was sparsely populated. With the retirement of the Concorde, the aviation world lost a symbol of speed and efficiency. Hermus was determined to not only replace the Concorde, but surpass it. Their vision of enabling flights from New York to London in just 90 minutes is much faster than the travel time of the Concorde, which was almost 3 hours. This is not only about speed, but also about efficiency and innovation that can change the way people travel in the future. Behind Hermus is H.J. Piplica, CEO, who has brought in talented engineers from well-known companies such as SpaceX and Blue Origin. The team is united by a shared vision to create faster, more efficient, and more affordable flights in the future. Hermus not only wants to dominate hypersonic flight in the atmosphere, but also help open access to space for millions of people around the world. Hermus's first step is to build a prototype hypersonic aircraft designed to exceed the speed of the SR-71 Blackbird reconnaissance aircraft, a legend that once held the world's speed record with Mach 3. To achieve higher speeds, Hermus needs a revolutionary engine that far exceeds the capabilities of conventional engines. Hermus developed a sophisticated engine called Sierra, a hybrid engine that combines turbojet, ramjet, and scramjet technology. These 3 types of engines have their respective advantages and disadvantages. Turbojets are ideal for launches from rest and low speeds, but are less efficient at hypersonic speeds. Ramjets and scramjets are very efficient at high speeds, Mach 5 and above, but are unstable at low speeds. The Sierra engine was designed to overcome these weaknesses by combining the strengths of all 3 engine types in one combined cycle system. In the early stages, Hermus used the General Electric J-85 engine, which had proven its reliability in various military aircraft, such as the F-5 and T-38 Talon. This engine was part of their early prototypes due to its cost efficiency and wide availability. In November 2022, Hermus achieved an important milestone in the development of Sierra, namely successfully testing the transition from turbojet to ramjet mode. This is a major technological achievement that demonstrates the potential of their hypersonic aircraft. The Sierra engine is designed to deliver the aircraft across a wide range of speeds, from takeoff to hypersonic speed. The development of the second generation Sierra aims to achieve higher performance. Hermus is planning a second generation Sierra, based on the Pratt and Whitney F-100 engines used in the F-15 Eagle and F-16 Fighting Falcon fighter jets. This engine has much greater thrust than the J-85, allowing Hermus to achieve higher speed and better endurance. The future of hypersonic aviation is not only focused on creating the fastest aircraft, but also on creating reusable technology to reduce costs and increase efficiency. Hermus's hypersonic aircraft are expected to not only open new transatlantic routes, but also change the way humans travel long distances. Imagine a trip from New York to Tokyo in just a few hours, or faster. Global connectivity for business and exploration, with efficient development costs of only $18 million for the first generation Red Sierra engine and an aggressive schedule, shows that great innovation can be achieved without a big budget, like NASA or other large aviation companies. With determination and innovation, Hermus is striving to bring the world into a new era of hypersonic flight, where distance is no longer an obstacle and speed is everything. Aircraft that use General Electric J-85 engines, such as the ones used in the development of the Hermus prototype, have not only recorded 16.5 million flight hours, but their total flight hours have exceeded 30 million in various types of missions and Air Force services in dozens of countries. This machine has proven to be very reliable and efficient, becoming the initial basis for Hermus to develop a new generation hypersonic aircraft. As part of their efforts, Hermus does not only rely on existing technology. The company has successfully developed and produced various advanced engine components, including the ram combustion air intake, pre-cooler, and the bypass system. All of these technologies will be integrated into the Sierra 2 engine, a further iteration of Sierra, which will later be used on aircraft. Their prototype, Sierra 2, was designed to be fitted to an aircraft with what Hermus calls a Darhorse Chaw, a much more advanced hypersonic engine. But they are not just designing one type of aircraft. Their grand ambitions include developing 3 different aircraft simultaneously. In addition to the main test aircraft, the Quarter Horse, they are also designing an unmanned hypersonic aircraft, UAVE, for national defense and security missions. The third is a hypersonic passenger aircraft, designed to cover more than 125 transoceanic routes at a speed 5 times faster than conventional commercial aircraft. Currently, their focus remains on developing the Quarter Horse as a first step toward paving the way for revolutionary hypersonic flight. The Hermus Quarter Horse roadmap begins in 2024 with the completion of Quarter Horse Mk-0 ground testing. This version is used to test various systems and technology integration into the vehicle. Testing is being conducted at Arnold Engineering Development Complex, the U.S. Air Force's complex in Tennessee. The tests included remote control and radio frequency latency evaluation, simulating emergency conditions such as loss of control signal. Hermus designed and built the Mk-0 in just 6 months, while the test was successfully completed in 37 days. A very impressive achievement. Shortly after, Hermus will introduce the Quarter Horse Mk-1, designed for the first flight in late 2024. From Edwards Air Force Base, one of the most historic air bases in the United States, Hermus completed the Mk-1 in just 7 months, setting a new standard for the speed of development of the Quarter Horse Evolution aircraft. From 0 to 3, if 0 and 1 use the Sierra engine based on the General Electric J-85, Then, the 2 version will bring major improvements. The Mk2 will use the Sierra 2 based on the Pratt & Whitney F-100 engine, the engine used by the F-15 and F-16 fighter jets. The Sierra 2 will be equipped with internal cooling technology, specially designed to deal with extreme temperatures at hypersonic speeds. In May 2024, Hermus began testing this new cooling technology with the F-100 engine, marking the first step in the development of the Mk2. The Mk2 version is expected to be able to reach speeds of up to Mach 2.5, far beyond the speed of sound. The goal is to demonstrate the capability of autonomous supersonic flight at speeds as high as a stepping stone to hypersonic flight. But the pinnacle of quarter-horse development will be reached in the Mk3 version, which is designed to break the current all-time airspeed record held by the SR-71 Blackbird. On this version, Hermus plans to demonstrate the transition from turbojet to scramjet mode in flight, which is key to achieving hypersonic speeds beyond Mach 4. Although Hermus has not set an official date for the Mk3 flight, they are committed to maintaining a fast and efficient production pace.